So next, we're going to start looking at an application of derivatives that we're going to call particle motion. And those of you taking physics, some of the ideas in here will be similar to some of the ideas that you've seen in physics. The idea behind particle motion is I have a particle that's moving back and forth along the x-axis. Why a particle? Because then we don't have to deal with things like friction or other things. There's just pure, smooth motion along the x-axis. And our goal is to analyze the motion of this particle. For example, we're going to say that a particle moves along the x-axis with a position given by s of t equals t cubed minus 6t squared plus 3t plus 10, telling you that t is greater than or equal to 0. T, that variable, is going to represent my time. I can plug in a time, and I can find my position. To give you a sense of what this looks like, let me show you on the calculator. Don't worry about how I type that in. Just watch the graph and watch the little dots and watch how it moves. You should have noticed it moved left at a point, it moved right at another point. It wasn't moving at a constant speed. At one point it stopped and changed directions. We're going to start our analysis of this today, but as we move through the course, we're going to add more tools to what we can use to study this particle motion, and we'll be able to do all sorts of analysis beyond our introduction stuff for today. The first thing I'd like you to do, which I feel like you can probably handle already, is what is the position of the particle at time t equals 3. What's the position of the particle at time t equals 3? Take a moment. I think you can figure this out. Just make sure you're showing your work. Not a lot of work, but show where you're getting your number from. Hopefully you realize it's just s of 3, which is 3 cubed, minus 6 times 3 squared, plus 3 times 3, plus 10. At this point, I'm going to go to the calculator, which is perfectly fine. I guess I should have said that earlier. Perfectly fine to use the calculator for these things. 3 cubed minus 6 times 3 squared plus 3 times 3 plus 10. And I'm getting a position of negative 8. Part B. Create a function for the velocity of the particle. We're going to create a function for the velocity of the particle. Velocity is basically the speed of the particle. How fast is it moving? Not totally, though. Those of you who've taken or are taking physics know that velocity also has a direction associated with it. So it's speed with direction. Are we moving quickly to the right? Are we moving slowly to the left? Things like that. Now, to find our velocity, the velocity is just the rate of change of the position. Change in position over change in time. I don't want to find the velocity over an interval. Instead, I just want to find the velocity right at time 3 or time 4 or anything like that. Well, a rate of change, an instantaneous rate of change, is really just the derivative. The velocity, v of t, is going to equal the derivative of position. And this is a big deal. I'm going to write down that formula, and I'm going to also write it in words. The velocity is the derivative of the position function. The velocity is the derivative of the position function. Which means if I want to calculate my velocity, all I have to do is find the derivative of this formula. Well, take a moment and go do that. derivative of position should be 3t squared minus 12t plus 3. And I have my velocity formula. Easy next question. What is the velocity at time t equals 3? Go find that. Velocity at time 3 is 3 times 3 squared minus 12 times 3 plus 3. I could do this, but I'm just going to go to the calculator. That's fine. 3 times 3 squared minus 12 times 3 plus 3. I'm getting negative 6 out of that. So by now, I have two formulas that I can work with. I have my position formula. By the way, this part's just saying t, your time has to be greater than or equal to 0. Wouldn't make sense to talk about negative times. And I have my velocity function over there, which is also valid only when t is greater than or equal to 0. I just didn't write that out. That still carries over. Part D. When is the particle at rest? When is the particle at rest? And I guess my question for you is, if the particle is not moving, something's going to be 0. And what's going to be 0? Is the time of the particle going to be 0? Is its position going to be 0? Or will its velocity be 0? What do you think? Well, hopefully you said velocity. When is the particle at rest? When the velocity is 0. So I'm going to go and I'm going to take my velocity and I'm going to set it equal to 0. 3t squared minus 12t plus 3 equals 0. All I need to do is solve this now. Well, it's not factorable though, which means we need to go and use the quadratic formula. Now, hopefully by now I've given you a program on your calculator that will do the quadratic formula. We don't need to actually go through the whole formula and all that stuff. If you just give this equation on the AP exam and then just go straight to the solutions, they are okay with that on the calculator part. So we're just going to go to the calculator and use that program that I gave you. So I'm going to go to the calculator, and if you push the program button, PRGM, it should bring up that program that I gave you called Quad Form. Push enter. Enter to run it, then it just asks me for the A value, the B value, the C value. Well, A is 3, B is negative 12, C is 3. I'll type those in, and it's going to solve my quadratic equation. It's going to give me these two values for my time. So at both of those times, the particle is at rest. Now, as far as decimals and the AP exam goes, the AP exam requires all answers given as decimals to be accurate to at least 3 places. What I mean by that, and what they mean by that, is we're going to say t is about 3.732 would work as an answer, rounding this to the third decimal place. And 0.268, again rounding that to the third decimal place. Their rule of accurate to at least 3 places means if instead of writing 0.268, you wrote 0.26794 because you didn't trust your rounding, that would be totally fine because this answer rounded, when they rounded, would give you the correct answer to 3 decimal places. So that's going to be my rule every time we use the calculator in here to give an answer accurate to 3 decimal places. There were 2 times when our particle was at rest. It was at rest in the beginning for a split second at 0.268, and then again at 3.732. Next, when is the particle's velocity 8? When does the particle have a velocity of 8? Well, what you're going to need to do here is set your velocity equal to 8. I'll take my velocity function, 3t squared minus 12t plus 3 equals 8. Well, I think you can use the quadratic formula on this as well, but you first need to make it equal 0. Go, make that equal 0, and use your quadratic formula program to find the time when the velocity is 8. 3t squared minus 12t minus 5 equals 0. I'm going to my calculator with that quadratic equation now. 3, negative 12, negative 5. And I'm getting 2 times here. However, remember that we said that t had to be greater than or equal to 0. I'm actually not going to care about both of these. I'm just going to care about that top one. And I'm going to say t is about 4.380. Let me show you one more example of this. And I need my functions on this page so I can see what's going on. I have my position, which is t cubed minus 6t squared plus 3t plus 10. And I have my velocity, which I calculated to be 3t squared minus 12t plus 3. We're going to call this part f. And I'm going to ask, what is the particle's velocity when its position is 7? What is the particle's velocity when its position is 7? So it's moving along the x-axis. When it reaches 7 on the x-axis, on that number line, how quickly is it moving? What's its velocity? Take a moment and just copy that down. What is the particle's velocity when its position is 7? Okay. Well, the first thing that I need to do is, well, I need to set my position equal to 7. I'm going to get 7 equals t cubed minus 6t squared plus 3t plus 10. And I need to go solve this equation. First going to make it equal 0. And I'm going to get t cubed minus 6t squared plus 3t plus 3. And that looks unpleasant. Anytime we're using the calculator and we get an equation that is unpleasant to solve by hand, our trick is going to be solve it by graphing. So that's what I'm going to go do. That's why I put that in your summer work. We're going to solve this by graphing, which means I'm going to graph the related function. I'm going to graph y equals x cubed minus 6x squared plus 3x plus 3 and find where that thing crosses the x-axis. So I'm going to type this in over here. I've got x cubed minus 6x squared plus 3x plus 3. You know what, I'm going to make the video pause. When you're set to move on, push continue. So I'm going to go graph this, and I'm going to get something that looks like this. And looks like there are 2 places, actually 3 places where it crosses the x-axis. 1, 2, 3. But I'm not going to care about this one because the time is something negative. So I'm just going to focus on this one and this one. I'm going to go do second calc. Find my zeros. I'm going to move a little to the left of this x-intercept and push enter. Then I'm going to move a little to the right of it, push enter. Enter for my guess. Take a moment, and you go find that. Let's see, looks like our first time is about 1.155. And now, when I'm done, I need my final answer to be accurate to at least 3 places. Because of how rounding errors work, I want to give this time to more places just to be safe, because I'm going to have to go plug this time in, and I don't want the rounding to kind of compound itself to make my final answer not accurate to 3 places. So I'm going to give a little bit more over there. Go find the other time when the position is 7. Go do second calc and find that 0. So about 5.332, but I'm going to write 1810 because, again, I'm going to need to use these. This is not my final answer. These are just the times when I reach a position of 7. What you now need to do is find the velocity at those 2 times. You need to plug those into your velocity. Plug in t equals about 1.1552404, and go find your velocity there. So 3 times 1.1552404 squared minus 12 times 1.1552404 plus 3. So I'm going to plug that in. Getting a velocity of about negative 6.857, and because I am done, I'm just going to round to 3 places, and I'll be good with that. Do the same at the other time. So let's see, 3 times 5. So I'm getting about 24.303. What's the velocity when its position is 7? Well, I couldn't do that directly. I first had to figure out the 2 times when the position was 7. Then I plugged those into my velocity formula and got the velocity at those 2 times. One other quick example I want to show you. If the position of a particle is s of t equals 6 sine t minus 4 cosine t, we're going to find the velocity at t equals 2. If the position of a particle is s of t equals 6 sine t minus 4 cosine t, I want to find the velocity at time 2. Well, first of all, go create your velocity function. The velocity of my particle should be the derivative of position, so it should be 6 cosine t minus 4 times negative sine t. So I can say my velocity is 6 cosine t plus 4 sine t. That's my velocity function. To find the velocity at time 2, I'm just going to go and I'm going to plug in 2. 2, not 2 pi, so it's not going to be a great number answer. But make sure, so we're going to go to the calculator for this. Make sure your calculator is in radian mode. This class is always done in radians, which is going to make it a little complicated if you're taking physics right now, because physics is always done in degrees. You're just going to have to remember to keep switching your mode. Go to the calculator, change your mode, and let's find, oh, it looks like I'm already in radian mode. Change your mode and go find the velocity at time 2. So let's see, 6 cosine 2 plus 4 sine 2, and I'm going to get 1.140.